Hello everyone, welcome to Prayogik Uno channel. In this video, let's discuss about the internal block diagram of 555 timer. So the internal block diagram of 555 timer can be divided into 4 different blocks. So the first block is the resistor divider network, and the next block is the comparator block, and next is the flip-flop block, and next is the output block. So let's look at the first block, which is the resistor divider network. If you are not aware of what is a resistor divider network, please watch the video about resistor divider network before you proceed. Link for the video is provided in the description box below. As you can see, there are 3 5K resistors here connected in series. And you can guess from where you got the name 555 timer. Pin number 8 is VCC and pin number 1 is ground, and 3 5K resistors are connected between pin number 8 and 1. So by applying the voltage divider network rule, the voltage at this particular point is 2/3 of VCC, and the voltage at this particular point is 1/3 of VCC. And you can see that at the next stage we have 2 comparators. The negative terminal of this comparator is connected to this particular point, which is 2/3 of VCC, and if you look at the second comparator, the positive terminal is connected to the reference voltage point, which is at 1/3 of VCC, and the other 2 inputs of the comparator goes to pin number 6 and pin number 2 respectively. And the next block is the RS flip-flop block. So you can see that the comparator, which has a reference voltage of 2/3 of VCC, is connected to the reset pin of this flip-flop, and the comparator, which is connected to the 1/3 VCC reference, is connected to the set pin. So the input for the flip-flop will be provided by the comparator based on the voltage at pin number 6 and pin number 2 respectively. And at the output block, we have a buffer here. So this is actually an inverting buffer, and the 555 timer IC has a very high sourcing current capability, and this capability is provided by this output buffer block. This enables the 555 timer IC to provide high currents of up to 200 milliamps. And there is also a transistor, the collector of which is connected to pin number 7, and it's called as discharge pin. When we discuss about different circuits like the astable multivibrator or monostable multivibrator, we'll look into detail of how to use this transistor and the discharge pin. So let's try to understand the overall working of this 555 timer by giving inputs to pin number 6 and pin number 2, and let's understand how the various voltages at these 2 pins will affect the working of the circuit. Now let's assume the voltage goes above 2/3 of VCC, and since pin number 6 is connected to the positive terminal, as soon as the voltage at this terminal goes above 2/3 of VCC, then the comparator provides 1 to the flip-flop. And since this is the reset input, the output will be reset to 0. And as soon as the voltage goes below 1/3 VCC at this particular comparator, you can see that the negative terminal of the comparator is connected to pin number 2. And as soon as the voltage at pin number 2 goes below 1/3 of VCC, then this particular comparator will kick in, and this will be 0. So the input for the flip-flop will be as set. So the output will be set now. So this way, by controlling the voltage at pin number 6 and pin number 2, we can actually toggle the output pin. So there are 3 different modes in which 555 timer is very commonly used. So the first one is called as a monostable multivibrator mode, and the second is called astable multivibrator mode, and the third one is called bistable multivibrator mode. So out of these 3, the most common are astable multivibrator mode and monostable multivibrator mode. So in the next videos, we'll be discussing how exactly we can build circuits for the astable and the monostable multivibrator modes. And also observe that there is a reset pin for this flip-flop. So irrespective of what the input voltage is, you can reset the output by providing a low pulse at this pin number 4. So for a normal functioning of 555 timer, so the reset pin should be at high level, and if you want to reset the output irrespective of what is the input voltage, you can provide a low pulse at this reset pin and reset the output. Similarly, we have pin number 5, which is called as control voltage. connected to the negative terminal of this comparator. So you can see that this is same as the point wherein we have 2/3 of VCC. So basically this control voltage pin can be used to change this particular reference voltage. So this is the overall block diagram of 555 timer. So remember that we have two pins, pin number 6 and pin number 2. So based on how we change the voltage at pin number 6 and pin number 2, we can control the output in different patterns. I hope you are able to get an overview of the block diagram of 555 timer in this video. So going ahead, we'll look at different ways to configure this IC in astable or monostable multivibrator mode. So thank you for watching the video.